welcome back everyone. And today I'm going to talk about this one right here, the actinides, which this is the second last video in this series, unfortunately. But I have lots of cool things prepared. And I'm only moving on to the actinides because the lanthanides aren't complete yet, because I am missing this element, this one, 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 and this one. So I thought we might have to skip to the actinides and then come back to the lanthanides another time. So unfortunately that's what it is, and I'll get started. For actinium, I collected some aragonite, which is basically calcium, but it can contain little bits of audinite, giving it the yellowish tinge on it. The audinite has actinium in it, hence the name. For thorium, I decided to collect some iron beads that formed during one of my thermite reactions. If you don't know, thermite is a reaction between iron oxide and aluminum powder. I collected these little metal beads because when thermite reacts, the slag does contain thorium, because thorium is the most abundant radioactive metal. And by the way, this whole group is radioactive. For protactinium, I collected amethyst because if you see here on the edge where it's cut, you can see there's a little gray lines. The gray lines contain the mineral tobernite, the uranium, and it decays to form protactinium and then decays to actinium and then so on. Protactinium can be found in ancient muds and sands. If you have a Geiger counter, you might notice that. For uranium, I collected another piece of my meteorites because meteorites do have a significant source of uranium, but very little. And uranium is known a lot because uranium is named after the planet Uranus, and uranium is the first radioactive metal to be discovered. Neptunium is named after the planet of Neptune, and Neptunium, I collected for this metal, I collected rose quartz. It has the pink tinge comes from titanium ores, but the titanium ores does contain neptunium, uraninite, which does decay to neptunium, and neptunium can be created artificially as well. For plutonium, it's named after Pluto, and I collected a piece of amazonite and the green tinge. It's interesting. The green tinge comes from mineral microline, and the microline has uraninite in it, and the uranium decays to plutonium. If you don't know, plutonium barely exists in the Earth, so it is very rare, and it glows red from the heat of its radioactivity. So this is just an idea to get you how radioactive this thing is. Americium is empty because this is too hard to collect. It's artificial. And the last 8 others are artificial as well. This can be created in nuclear reactors, and americium is the most common radioactive element used in the house. Fun fact, americium is used in smoke detectors. The americium makes an electric current in the air, and when smoke disrupts the electric current, an alarm goes off, warning you there's fire going somewhere in your house. Americium decays to neptunium as well, so. Curium, empty. This is artificial as well, named after Mary Curie. This element was first synthesized by Glenn Seaborg, and he won the Nobel Prize for neptunium. It's the first element discovered to be heavier than uranium. Berkelium is empty. Berkelium is named after Berkeley campus in California, the university, because they can have a cyclotron to produce new elements, and it produced, in history, it produced about 5 elements, a little bit less than the super heavy element factory. Californium is empty. californium is empty. Named after the state of California, discovered by Berkeley laboratories. And californium is used to treat cancer. Californium-90 produces lots of neutrons, and that's why it is used a lot. But it decays very fast, so it's hard to get hold of. Many of you are going to like this next element, Einsteinium. Einsteinium is, lots of my friends love this element, only because it's named after Einstein. It's number 99. It is found in the test of an atomic bomb. Einstein, only a few milligrams of this silvery metal that glows in the dark is discovered. Einsteinium is loved by many because this is number 99, and it is the last metal that has a known melting point and boiling point. Fermium does not have a known boiling point or melting point, and so the others after it. But the others before, we already know the melting points and boiling points, because the last few are very, very, very unstable. And fermium, this is number 100. Very little people know about this. And fermium is named after Enrico Fermi, which is the person who made the first nuclear reactor. Fermium is also discovered in an atomic bomb test. And fermium is a silver metal with a yellow tinge, similar to the metal scandium or silver. And so if you have seen these metals, you would definitely know what this metal will look like. Because I searched up images on Google, and it showed like a yellowish silver plate. Mendelevium is named after Dmitri Mendeleev, the creator of the periodic table. And Mendelevium is number 101. This metal is very little known about this metal, so I'm not going to talk about it. Nobelium, named after Alfred Nobel, the creator and the founder of the Nobel Prizes. Nobelium was discovered by Albert Gornoso, which discovered 12 elements in the 20th century. So this element is pretty young, but not as young as tennessine, which was discovered in 2007. But nobelium, it has a weird chemical symbol. The chemical symbol is No, but it's a little bit weird. But I still love this element. Lawrencium is probably my favorite element. It's named after Ernest Lawrence, the creator of the first cyclotron. He made this at the Berkeley University, and Lawrencium is produced in very tiny quantities. Very little is known about it as well. And it's empty. I want to collect it, just like me. And yes, thank you for joining me, and I'll be waiting for you in the next one. Talk to you then.